circumference and arc length. Before I start talking, we need to know what circumference and arc length is. Circumference is the distance around the circle, and arc length is the portion of the length of the circumference. Here. The formula for circumference is pi d. The formula for arc length is the measure of arc length AB divided by 360 degrees and then multiply 2 pi r. Areas of circles and sectors. To find the area of a circle, you use the formula pi r squared.
The area of sector equals the measure of the arc angle over 360 degrees, then you multiply by pi r squared. Areas of regular polygons. The area of a regular polygon is A equals 1/2 AP. The lowercase a is the apothem, while the uppercase P is the perimeter of the polygon. The radius of a regular polygon is also the radius of a circle. The apothem is the distance from the center of a regular polygon to any side of the polygon. This is the apothem. It forms a 90-degree angle. That means when this apothem is not known, you can use trig functions to find it. The apothem also hits directly in the middle of a side. Hence, this part and this part are congruent. Yellow and green is the central angle of a regular polygon. It is an angle formed by two radius drawn to consecutive vertices of the polygon. To find the measure of each central angle, divide 360 degrees by the number of sides the polygon has. Use geometric probability. The probability of an event is the measure of the likelihood that the event will occur, while geometric probability is the ratio about a geometric measure like length or area. An example of property of length would be like this. The probability of K being on CD would equal the length of CD over the length of AB. An example of probability of area would be the probability of K in region M equals the area of M over the area of J. Explore solids. The picture below is a polyhedron. A polyhedron is a solid bound by polygons or faces that enclose a single region of space. This is Euler's theorem. Euler's theorem focuses on the number of faces, vertices, and edges of a polyhedron. The formula is faces of a polyhedron plus the vertices of a polyhedron equals the edges of a polyhedron plus 2. A polyhedron is regular if all of its faces are congruent regular polygons, and convex if 2 points on its surface can be connected by a segment that is inside or on the polyhedron. The polyhedron on the right is a regular polyhedron and it's convex. The polyhedron on the left, however, is not convex, therefore it is concave. This picture shows cross-section. Cross-section is the intersection of a plane and solid.
So you learned from the great minds about the basics of 3D solids. Now I, the great gentleman, will tell you how to find the volume of these solids. Volume is the amount of space the object contains. You can find the volume of a prism or cylinder by using a formula V equals BH, where B is the area of one base and H represents its height.
The volume for a right cylinder is pi r square h.
Volume of pyramids and cones. The formula to find the volume of a pyramid and a cone are similar to the volume of a prism and cylinder. You just multiply 1/3 to the area of base times height.
11.8 Surface area and volume of sphere. Sphere is the set of all points in the space that are equal distance from a given point. You might know it as this solid. To find the surface area of a sphere, use this formula, 4 pi r squared, and use 4/3 pi r cubed to find the volume. 11.9 Explore similar solids. Two solids are similar if they are the same type of solid with equal ratio corresponding for the linear measurement like height and radii. The common ratio is known as scale factor. The similar solid theorem states that if a similar solid have a scale factor of a to b, its corresponding area will have a ratio of a squared to b squared, and its volume will have a ratio of a cubed to b cubed.